This video concerns the analysis of variance, a very powerful statistical technique that allows us to look for significant differences among treatments or groups. So we're going to start by opening up our tree swallow data set, again available on the biology department website. And in this case, if we go to the data browser, we remember that there are 3 different states where these tree swallows were banded. And what we might want to know is, are the tree swallows in Alaska different in size than those in Maine, and are they different from those in Vermont or in Alaska? We'll close out of the data browser here, and we're going to go up to statistics, and we're going to choose linear models, and we choose analysis of variance and MANOVA, which is multiple analysis of variance, and we're just going to go down and pick one-way ANOVA. One-way ANOVA. Our response variable, what we're measuring here, is going to be the weights of these tree swallows, and we're going to classify them according to our state. So that's the area. What this analysis is going to tell us is whether or not there is a significant difference among one or more of the states. But we're not going to know exactly where those differences lie unless we do what are called multiple comparison tests. So we need to choose at least one of these to make the analysis of variance even more useful. And the one I prefer is the Chef-A test, but Bonferroni or CDAC are fine, but choose one of those at least. And we're going to click OK. And here is our analysis. The analysis of variance calculates a statistic called the F value. And the F value is really a proportion of the variation due to variation between the groups, that is between Maine, Alaska, and Vermont, and the within group variation, how much variation there is in all the Maine birds, in all the Alaska birds, in all of the Vermont birds. And what you can see is this value is huge. It tells us that there's a whole lot more variation between groups, that is among the 3 states, than there is within a state. And our hunch that this might be a really strong, significant relationship is confirmed by looking at the p-value. So the probability that these differences would have arisen by chance is virtually 0. So we can rejoice in the fact that we have found significant difference among some of the tree swallows in our study. But again, we don't know where those differences lie. So what we would need to do is to take a look at the Chef-A, the results of the Chef-A test. Before we do that, let's go back into our data, and what we're going to do is to, we can just go up to the summary data here, like we've done before, and calculate summary statistics. And I'm interested in the weights, and I want to break this down by state. So I'm going to use area, and I'll say OK. So here are my 3 different averages for the 3 different areas. The Alaskan birds mean of 26, the Maine birds mean of 20.1, the Vermont birds 19.8 or so. So what does the Chef-A test tell us about that? Well, we can still see the results of that here. These numbers above represent the Chef-A statistic, which by themselves don't have much meaning. What we are really interested in are what these values here, the second values, are. These are the p-values. And so what this tells us is that if we compare Alaska to Maine, the probability that the differences that we're seeing arose by chance is virtually nil, that the probability of that happening is 0 out to 3 places. So Maine birds are not as heavy as Alaska birds. We can show that statistically. Similarly, Vermont birds are lighter than Alaska birds, so our p-value is very small. But between the Vermont and Maine birds, our p-value is 0.909, which is very high. That means that there's really no way that there's any difference between the heaviness of Maine birds and the heaviness of Vermont birds. Remember, our critical value that we use mostly in biology, or most of the time in biology, is a 0.05 p-value. So if a p-value is greater than 0.05, and 0.90 clearly is, then we would accept the null hypothesis that there is not a difference between these two groups. So what our analysis of variance showed us up here is that, yes, there is a difference somewhere in your data set of some of the areas, but we don't know exactly where they were. But we explored those differences in a pairwise fashion by making all the possible pairs of these three states. Maine and Alaska, clearly different. Vermont and Alaska, clearly different. Maine and Vermont, not different at all.